we've got to the rules for differentiation. So these are like shortcuts. You don't have to use that limit definition anymore. That's pretty sweet. Something to recall is that the derivative represents the slope of the tangent line to whatever function at some x value. That's something to keep in mind throughout all of this as I go through these differentiation rules and then maybe a couple of examples. So I'm just going to write down a bunch of them and then talk about them. First of all, if c is a constant, the derivative of any constant function is 0 because the slope of a constant function is 0. Remember, constant functions are just horizontal lines. So an example of this would be like if I take the derivative of 2. Well, that line would be 1, 2, y equals 2. What's the slope of that? That's 0. Okay, easy. The derivative of some function with an exponent, you just bring the exponent down, m, and then times x to the n minus 1. This is the old power rule. Yeah. So let's look at a quick example for that. First, I'm going to combine some rules. So the derivative with a constant, you can really take the constant out front, so it's like 3 times. We don't really do this. We do this without thinking. Sorry, it's not n. Sorry. So first, we can take the constant out front, and then bring the 8 down, so it'll be 8 x to the 7th, right? You subtract 1. But then it's times that 3 out front, so that would be 24 x to the 7th. Easy. Easy peasy, lemon squeezy. Why you squeezy these lemons? They're not your lemons. Take them away. Also, if you're adding two things together, you could just take the derivative separately. That's pretty simple. So if you have a polynomial, so if you have maybe like, you take a derivative, the derivative operator of x squared plus 2x minus 1. You can just take the derivative of x squared, which is 2x raised to the 1 power, plus the derivative of a constant. That just, sorry, let's think about this, because lots of people used to get this wrong. So, it'll be to the 1, so 2 times the 1, that's just 2. And then x to the 1 minus 1, that would be 0. X to the 0 is just 1. So really, the x just goes away. That's what you can think of. And then minus the derivative of a constant, that's 0. So there you go. You could just take the derivatives separately. I should say plus or minus there. Okay. Then we have the product rule, which is, this is what I'm going to say. First d second plus second d first. That's how I remember the product rule, where this is the first, and this is the second, and the derivative would be f prime. So d first would be f prime, d second would be g prime. So what does that look like? First, I will say first, d second, well, that's g prime of x, plus second, g of x, d first, times f prime. Oh, that's beautiful. That's so easy. And then now we look at the quotient rule. So this is what I would remember if you don't have a way of remembering it already. But there you go. First d second plus second d first. This quotient rule. If you're taking the derivative of two functions divided by each other, then you would have low d high minus high d low. Square the bottom and away we go. That's how I remember the formula. Low d high minus high d low, all over low squared. That's what some people remember. So what does that look like? Low would be g of x. D high would be f prime. High d, that would be f prime. Low d high minus high, high d low, that would be g prime. There we go. So low, which is g of x, low d high, that would be f prime of x, minus high, which would be f of x, d low, that would be g to prime, low d high minus high d low, all over low squared, or square the bottom. So d should be g of x, and then we square it. Yeah. If you remember this, it's very easy. Low d high minus high d low. Square the bottom, and away we go. All right. That's pretty good. I think I will start. These are the basic rules for derivatives, so you don't have to use that limit definition. These are all the shortcuts. And that's the end of this video. I'll do examples in the next one.